Range is a measure of variance. These first four things we did right here were measures of center. The mean, median, mode, and mid-range tells us, well, about where the data is centered around. The range, however, is a measure of variance, and it tells us how scattered the data is, how far all over the map it might be. Now, a large range doesn't really tell us very much. A small range tells us a lot. But let's just, before I get into the theory behind this, let's just talk about how to find the range. Basically, we just take the largest value of each data set, and from that, we subtract the smallest data value. So we're going to type in equals, and how do we find the maximum data value? That's right, we type in max, open parenthesis, grab the first one, go down past that last one. Okay, and then minus the smallest value, which, let's see, we would use min. Grab the first one, go down past the last one, close parenthesis, press enter. Okay, now that has a mean of 45, median 45, mode 45, mid-range 45, and a range of 52. Well, that's a pretty big range considering that the mean is only 45. So, let's try another measure of let's try another measure of variance, or it's also called measures of dispersion. Either one of those two are the correct terms, but basically they tell us how scattered these things are. And if you remember from class or your notes or the book, this S with a little 2 next to it, it means the sample variance. Remember, if it has a letter of the English alphabet, then it's a sample statistic. If it uses a Greek letter for a symbol, then it's a population parameter. I said that S with a little 2 next to it is the sample variance. So variance, let's try typing in equals VAR. And if we take a close look, again, you have a couple of these legacy functions here, so we're not going to use those. And I said we're going to find the sample variance. So that's this one, var.s for sample. And I'm going to grab the first one, go down to the 20th row on this, and then close parentheses. Okay, now for right now, this sample variance is just a number. It's meaningless to you. We don't really learn about what the variance means until unit 3 in this class. So for right now, it's just a number, it's a calculation, and I will talk more about it after we get the variance and this last one, just the S, for all of the data sets. Now, from the formula, which is a really long, crazy formula for variance, if we take the square root of this number for the variance, we would get this last thing called the standard deviation. But I don't want to take the square root of it. I just want to calculate the standard deviation directly. So in order to do that, I'm going to type in equals, let's see, standard ST, and here we have stdev.p. Well, that's population. We're not working with a population. We're working with a sample. So stdev.s for sample. And I grab the first one and go down past the last one. Closing parenthesis, press enter. So for this one, I have a range of 52, a variance, S with the little 2 next to it, sample variance of 183 and change, and a sample standard deviation of 13.5-ish. So let's drag and drop all these functions across to see what the other ones are. Now, if I take a look at just the ranges, 52 is a pretty big range. 48 is also a pretty big range when you're comparing it to a mean, median, mode, and mid-range of 45. 32 is, well, that's a little bit better. And 18, that's probably even better. Now, if I were Howie and I just knew this information, just the mean, median, mode, mid-range, and then the ranges for each, then what I would do is I would eliminate these first two and then maybe these last two. And probably if all I had is the range, I would probably pick this last one, E harmonica. But let's take a look a little bit further. Here I have a variance of 32 and change, and here I have a variance of 43 and change, almost 44. And then when I go to standard deviation, because usually when we compare these things, we look at the standard deviations. This one has a standard deviation of 5.7-ish, and this is 6.62-ish. And then if I take a look at these two, their standard deviations are much higher. So let me explain to you what that means. If I looked at all of these, this is a measure basically of how scattered or how dispersed the data is. And if I take a look at 15 and I compare it, say, to 6, well, 6 is a much smaller standard deviation, which means my data is much less scattered. And all things considered equal, all other things with the measures of center, then this 6.62 is a way better number than this 15.9961 as far as the data being more condensed. In other words, less scattered. But this one is the best one. And here's why. All other things being equal, meaning the mean, the median, the mode, and mid-range, they are all 45 for all of these. But this one, the zoo.com, that one has the smallest standard deviation. And because it has the smallest deviation, it means it's the less scattered, which means that all of the numbers are much closer to 45 on this one than on any of the others. So let's take a look at it and compare these last two. You know, I just have like 44, 45, 45. All right, well, this 61 is way up there, but 45, 45, 45, and then 47 to 43, and so on. And basically, it's just two outliers, two that fall really far from that mean, which is this 25 and this 61. All of the others, if I said 25, I meant 29, and the 61. But all of the other numbers are very close to 45. If I take a look at this last one, I have quite a few other outliers. That means that this one, even though it has a smaller range, the data is way more scattered. There are very few numbers that are right near my mean, median, mode, and mid-range. So if all that Howie saw was the statistics for the samples that were here, I would say that the best one for Howie to choose would be this one, zoo.com. So you go, Howie. That's the one. Anyway, that is all for today. Hope you enjoyed it and have a great day. Bye.